Hi, it's Sam from the Math Easy Solution. Trying to discuss further into integrals and areas between curves, and now look at basically some examples and go over part 1 of the example series. And I'll solve these two examples. I'll go over example 1 first, which states find the area of the region bounded above by y equals ex, bounded below by y equals x, and bounded on the sides by x equals 0 and x equals 1. So I'll go example 1 right now. Basically, so if we were to graph this out, graph it out, basically we have it's bounded above by y equals e to the x. So we know how that looks like. It looks something like this, where this at here is it's always going to be 1. And now we want it, so this is the y equals e to the x curve. Now it's also bounded by below by y equals x. That's just a straight line going from the origin. It looks something like this, and this is y equals x, and it's bounded between x equals 0 and x equals 1 right here. So we got 0. And now we got up to here, so we draw a vertical line. This is x equals 1. So this is that region we want to find the area of. And like I showed in my earlier video, it's basically going to be, all it's going to be is the integral. So we'll go, let's call this a equals the integral from, well, 0 to 1, that's 0, to 1, now we'll go x equals 0. To 1 of, now the top function, that's just e to the x. The bottom one, that's just x. And then dx right there. So we would just write this out. And now the integral of we do it separately. Integral of e to the x is itself, because the derivative is itself. And now integral of x, that's going to be x squared divided by 2. So you make it a 2 and then divided by 2, just so if you take derivative, this 2 goes down, they cancel. And it's from 0 to 1. So we write it like this, and this basically means e to the 1, not 0. E to the 1 minus 1 over 2. 1 squared is just 1. And then we subtract by, well, e to the 0 minus, 0. Right there's plug in 0 in there, and we get basically e minus 1 over 2, this is going to be 1, and then minus 1. So this equals to e minus 3 over 2, and that is our answer. And now that brings us to example 2, and the difference between this one is we're not given the points x equals 0 or 1, etc. We're not given that. We're just given basically find the area of the region enclosed by the parabolas y equals x squared and y equals 2x minus x squared. So what this means is, if you were to draw this out, so the y equals x squared looks something like this. That is basically y equals x squared. Now this is a downwards facing parabola because there's this negative x right here, and when you plug in 0, it just becomes 0. So it looks something like this actually, or it might not be this might not be to scale, but anyways, it looks something like this. This is going to be equals to y equals 2x minus x squared. So this is just a parabola going down. And now, as you can see here, this is the region enclosed by it. So we have to find out this x value and this one right here. But we can look at it, then it's going to be 0, but we'll prove it soon. And to do that, it's when basically both of these functions equal the same one at any particular x value, at these two ones. So we could write down, to find these 2 points, we go x squared equals 2x minus x squared. So we solve for this. We can bring this x on this side. So when we bring it on this side, this will just be 3x. Actually, whoops, not 3, I mean just 2. My bad. Basically, 1 plus 1 is 2, not 3. And this is squared equals 2x. Right here, you could bring it both actually. So we'll get, if we just take both of them out of there, minus 2x equals 0, and now we can take the 2x out. This will just be x minus 1 equals 0. So this is true when x equals 0 or x equals 1. So we have the 2 points. This is equal to 1. This is when these two functions are equal. So now we basically have these 2 points, and we could plug that into the integral. So that's a. So we'll call that a. We'll go a equals to integral from 0 to 1 of the top function. This is the top one here, 2x minus x squared, and now subtracted by x squared dx. So we have that, and now this is just 2x. So we'll go, I'll just write it a bit better, 2x minus, and now this is 2x squared dx. And now the integral of this is going to be, well, this is going to be x squared. This is 2 over 2. So you always do that. Always just make this higher power and divide by 2. And now we go right here, which is going to be x3 over 3. So we just raise a power and divide by that power. This is from 0 to 1. Now when we plug in 1 inside, we'll get basically 1 minus 2 over 3, and then minus, when we plug in 0, that's just 0 on both sides. And now 1 minus 2 over 3, that's just 1/3, and that is the area. Anyways, that's all for today. Hopefully you learned, and stay tuned for later videos. I'm going to do examples where sometimes you just can't find these points, so you'll have to either use a graphing calculator, etc., and just estimate close enough points. Anyways, that's all for today. Hopefully you learned, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.